Hello everyone, welcome to AI Geek. Today our topic is data preparation. So we deeply explore this topic. So why we need data preparation? So let's begin with our first slide. Machine learning cannot give you benefit or cannot give you result or insight in the right direction unless you will feed the right or the correct data to the model. Correct data set, what does it actually mean? So what is a correct data set? As we know, data is the combination of information and noise. So correct data stand for the correct data is equal to minimum noise. So we have the data set, in it we have the minimum noise, so we have the maximum information in it. So today we're gonna see how to prepare the data for the better outcome. So how we can get the better outcome from our data. First of all, our tree start from root node is data preparation. We'll get the observation or row. So in our daily life, the horizontal things, or in our the table, if we have a tabular data, so we have horizontal lines or horizontal values in it, so we call it rows. Or for data science or data scientists mostly use observation. The vertical things or vertical line in the data, tabular data, so we use this a column, or data scientists use features. Next we have the record in the data set, we have values, and we have feature plus values. So each and every we will discuss in detail. First of all, observation. In the observation we have the rows, so we see the record, so either we have the duplicate or no, so we will remove the duplicate values. Next we remove the negative values. The negative values, for example, the things we cannot be possible in the negative. For example, if we have somebody measurement or the height of the someone, so if the height of the someone is 5.5, so it's mentioned the minus 5.5, it's not possible if somebody has a height in minus or in the negative value. So we have to treat these values carefully. Next we will see the outlier treatment. The outlier treatment, these are some extreme values in our data set, so we'll try to fix it, but this is a very important topic, so we will discuss it later in further detail. We will next go through to feature column and feature selection. We select the features on the basis of different things for our model. For example, we selecting the feature, the feature should be independent, they're not dependent on each other or among them. They have some, if they having some dependency in it, or they're dependent on some other feature or some other column, so we have to remove at one of them, or so we have to prepare the new variable from them. In the next, one hot encoding we usually using for factor or categorical variable, categorical features, so we'll discuss in later. I'll go through to the values. Value, we scale the data, we using the data scaling. There are some techniques, so we further explore this technique in the next slide. Next is imputation. We using the imputation method for missing value treatment. So we have some, it's obviously sometimes it's possible to we have some missing values in our data set, so we treat this, sometime we treat the data set missing values with central tendency, mean, median, mode, or sometime we, for example, we're working on OR, so we're using some one library, its name is mice, so we use the mice package, so we impute the missing values. Next is features plus values. So we dimensionally reduction we're using, so in both direction, either in the feature or either in the values, or either we have the records observation. So we remove, for example, we have 1 billion records, we cannot put the 1 billion record in our machine learning algorithm, or either we have 50 or might be 100 feature or 100 column in our data set, so we cannot, it's not possible, or sometimes we cannot do the 100 column put in or feed in our data set. So we use this dimensionally reduction. Even we say PCA or PCA, we say usually we use the PCA word or factor analysis for doing this thing. Next thing is outlier treatment. So how we treat outlier? Usually we see outlier removal. Mostly people are saying, or some new views in the data science or data analytics domain, people are saying outlier removal. So either it's a good approach to remove the outliers or no. So for example, we doing the outlier removal, maybe we removing the specific one population. Is it possible? For example, we have some extreme values in our data set. It could be possible. So mostly values or BP is normal, but somebody has high BP. So maybe high BP we shown is an outlier, but it's could possible somebody has some high BP or systolic BP 150. Or either we're doing the outlier removal, so maybe doing the right thing. So we remove our trash, or we remove our noise from our data set. So outlier treatment is very technique. It's very so it's a careful technique. So we think about it. So how we treating our outlier treatment? So for the best thing is we have to concern with the domain expertise. So we can discuss whether either this thing or this value we should remove it or not. We can see it. Our next thing is one hot encoding. One hot encoding we usually for factor or categorical variable. For example, we have low, moderate and high temperature. So usually we are doing 0, 1 and 2, or 1, 2 or 3, or either we have some colors, blue, green and red, blue for 1, green for 2 and red for 3. So for example, we put in this number or values in our machine learning model. So machine learning model, the 3 is extreme value or 3 is for highest, but it could not be possible. Some blue, green or red, 3 has an equal weight. So how we can treat this? So using this technique, one hot encoding, it's low. So we divide the categories in separate columns. So either we has or it's present or absent, if we have the category or no, we use the 1 and 0. Data scaling. Data scaling, we're doing the data scaling for two things: standardization and normalization. Standardization, we're using the rescale the data to have mean is equal to 0 and variance is equal to 1, and in normalization rescale the data into the range 0 or 1. It's very important thing. Data preparation is we pre-process the data. So either if we feed the correct data, so you'll get the better outcome, or for example if we not feed the correct data, so we cannot, our result is not much trustful, or we cannot say anything about it. So maybe we are getting some bad results, so it could affect our business or some of our outcomes. So be careful about this. Thank you for watching. Stay blessed. Thank you.